Alright, so here are the Unit 3 examples for Section 3.1. So, example 1, find three rational numbers between 1.25 and negative 3.5. So first, write these numbers on the number line. We know that negative numbers are to the left and positive numbers are to the right. So we will write these at the end of our number lines since we're trying to look at numbers in between the two. So basically what we're doing is taking the larger number line and zooming in on this area. Alright, so between our negatives and our positives, we know is the number 0. So let's choose that as one of our rational numbers. 0 can be written as a fraction, so therefore it is a rational number. Now between 0 and 1.25, the easiest number to pick out is the number 1. 1 can be written as any number over itself, so for example 1 over 1, or 3 over 3, or 5 over 5. So 1 is a rational number. And because we go all the way down to negative 3.5, we can also choose negative 1. So let's choose both of those as rational numbers. So there are three rational numbers between 1.25 and negative 3.5. Our second one, three rational numbers between 1 over 5 and 7 over 10. Again, let's write these on the number line. Our greater value to the right and our lesser value to the left. Now it's always easiest to look at fractions with the same denominators. So let's convert that 1 over 5 to 2 over 10. Now, because we have the same denominators, we can just look at the top values and find three numbers between 2 and 7. So let's use 3, 5, and 6. So, three rational numbers between 1 over 5 and 7 over 10 are 3 over 10, 5 over 10, and 6 over 10. Use a number line to order the following number from greatest to least to greatest, So, let's look at the negative numbers first. And we know the higher the value of a negative number, the farther it is from 0. So that actually means that it's less. So negative 2.3 is less than negative 1.25 because it is farther from 0. And now looking at our positive numbers, the three of them, there are no values in the 1 positions, so we must look at the tenths positions. And we know that 2 is less than 3 and 3 is less than 8. So we get 0.25 is less than 0.3, which is less than 0.8963. Then we just copy those numbers in the exact same order onto a number line. And we have used a number line to order the following numbers from least to greatest. So here we have fractions instead of decimals. First, let's convert our improper fractions for the negative numbers into mixed fractions. So 10 over 4, we divide 10 by 4 and we get negative 2.5. Then we can compare the negative values. We know because negative 2.5 is farther from 0, it is a lesser value. And then followed closely by negative 1.25, and then followed by negative 3 over 8. Now when we look at our positive values, we see that we have two fractions, two proper fractions of 9 over 5 and 7 over 10. So let's convert those two having the same denominator. So 90 is a common multiple between the denominators. So 7 over 10 becomes 63 over 90, and 5 over 9 becomes 50 over 90. So we can see that 50 is less than 63. So 50 is less than 63 over 90. And then because 8 over 3 is an improper fraction, we don't have to really convert it here because we know that it will be larger than those two, so it is our largest value. So then we just copy these values onto a number line, and we have now used a number line to order these values from least to greatest. So your turn, use a number line to order the following numbers from least to greatest. I will give you a minute to attempt this question. All right. So here's what I got for values listed from least to greatest. I'm not going to write it on a number line, but I believe you are capable of doing so. You just copy literally that order of numbers and draw a number line above it, or below it if you wish. So, practice problem number 1. Write the rational number represented by each letter on the number line as a decimal and fraction. So, any number that is a rational number can be written as in decimal form or fraction form. So first, because we're looking between 16 and 17, we should count the lines to see exactly how many lines there are because it's evenly spaced. And we can see that there's 10 of them. So let's label them. 6.1, 6.2, 16.3, 16.4, 16.5, 16.6, 16.7, 16.8, and 16.9. And now we can compare where our letters are on the number lines to the number line below. A is at 16.9 and B is at 16.5. So A is equal to 16.9 and B is equal to 16.5. And to write these as a fraction, we don't like decimals in our fractions, so we multiply our number by 10, so we get 116 over 10 and 165 over 10. Practice problem number 2. An expedition group sets up camp on the left side of a mountain and then sets out for their afternoon of exploration. When it was time for to return, John was 35.69 meters above the camp, Sarah 64.125 below, and their guide was 450.26 meters below the base camp. Write each hiker's distance above / below the camp as a rational number. So all we're going to do is write them as positive and negative values with respects to base camp. So let's write out John, Sarah, base for base camp, and the guide. We will use the base as 0 because we aren't told what the height is. So let's consider it the 0 or the start zone. John was 35.69, Sarah negative 64.125, and the guide negative 450.26. Now, as you can see, above, meaning going up, is positive, and below, meaning going down, is negative. Think of that as a vertical number line. Above, positive, below, negative. So above ground we have positive, and below ground we have negative. So continuing the practice problem to letter B, sketch and label a vertical number line to show the camp and the hiker's positions. So here is our vertical number line. Base camp, which we called 0. John is at 359 or 35.69. And then Sarah and the guide are below the base camp at negative 64.125 and negative 450.26. Okay, and our final question for this practice problem: which hiker is closest to the camp? Explain your reasoning. Let's compare the values. 35.69 is less than 64.125, which is less than 450.26. So 35.69 is closest to 0. So John is closer to the base camp because 335.69 meters is a smaller distance than 64.125 meters. Oh, there's one more. Which hiker is at the lowest altitude? How do you know? Well, if we're looking at our vertical number line, we can see that the guide is well below where Sarah is. So by examining the vertical number line, which represents the direction of a mountain, the guide is at the lowest altitude. And that is the end of our examples for this section.